Hello all and welcome to my YouTube channel. Welcome to the series where we are building agentic framework with the help of Microsoft AutoGen. In the last session, we have seen how we can use a code execution with the help of Docker and how we can enable that functionality at agent level so that our agent can execute a code at Docker environment. This is the 6th video in this particular series, and if you have missed previous 5 videos, then I'm not sure what were you guys doing. I would recommend go ahead and watch those videos because this is very interesting series going on, and I don't think you should miss out those videos. So please go ahead and check out those videos. The link is already available in the description. So let's get started with today's session. So today we are going to study how we can use a tool in AutoGen agents. Now, if you remember in last session, we have used a code executor in order to add a code execution functionality for an agent, and with that we have converted our agent into a smart programming agent. Now, though agent has the feasibility to generate the code, but it is not a recommended way because there is no control over the code that is agent are generating, because it is LLM powered and they can generate any code. And as we have seen that we can execute that code into different environment, we don't want to unnecessarily execute any code that may create any issue. And in order to avoid that, we should have a more control over the agents, and in order to add that control, we have a feasibility to pass tools. Now tools, we can feed it to the agent and which controls the agent behavior. So what exactly tools is? Tools are nothing but the functions. These are the functions that are predefined. Now, instead of asking agent to generate a code, we can have a tool where we can write a function where we can write our custom code, and that custom code we can execute with the help of agents. And these tools can help us in order to accomplish a task, like it can do a web search for us. We can write a custom coding to do the web search. Then it can call a custom APIs. Also, it perform calculation. So it has these functionalities available and many more. We can write a Python functions and we can feed that functionality. We can register those under the tool, and that's how it can generate the output. And as we have already discussed that, what exactly tools are doing, they are adding more control to the agent. So they control the agent behavior. Now let's understand how exactly we can add tools to the agent and how exactly the workflow works. So for example, we have an agent. Now this agent has its own prompt. To the agent we pass input user message, and that agent is responsible to generate the response or output. Now, in order to enhance the functionality of this particular agent, we can add a tool to this particular agent. Now, what exactly this tool is? Now, this tool is nothing but a function or Python function. Now we can pass this Python function to a tool, and then we can have a register in between. So this tool is going to register the functionality into the agent. And once the tool is registered to the agent, then it will help improve the output response. And these Python functions are nothing but we can control the input and output to these Python functions, as well as the output that it is generating. We can control that because we can define the return type of functions, and also for input we can define the input argument type or input parameter type. And in order to define that, we can use a framework called Pydantic. We are going to see this in the practical session. With the help of Pydantic, we are going to control the input parameter so that we are defining the input and output that is generated by the Python function. We are passing it to the tool. Then we are registering the tool, and that tool we are feeding to the agent, and that's how whenever user is putting any user message, it is going to generate the user response. I hope this basic idea is clear to you, and this is how exactly the function or the tools works under the agent. So you might be confused with Pydantic. So Pydantic is nothing but it is a Python library that defines the output format, or it performs the validation on your data. Whatever data you are passing to the function, it checks. Let's say in your input, if you are passing a input value as a integer, then the Pydantic will help you check before passing the value to the function whether it is integer or not, and that helps in order to maintain the data consistency, as well as it helps detect the errors at early stage. So that is the Pydantic, and we'll see that in the practical stuff. So without wasting time, let's jump onto the practical, and where we will be adding a tool functionality to an agent, and we'll see how exactly we can improve the performance. Let's jump onto the code. So now we have opened the code. So let's create a new folder for testing the tool. So I'm creating a folder name called tool use, and under that tool use, we'll be creating a Jupyter file. So under tool use, let me create. Okay, so we have created the file. Let's select the kernel. Okay, we have selected the environment. Okay, let's import the required dependencies. So we are importing sysOS in order to set the path directory. Then convertible agent we are importing. And this, if you remember in last session, we are going one step back in order to access the LLM config, because the LLM config is available at this particular root level, and we are under tool use folder. That's where we are setting this path, and from there we are importing the LLM config. So let's execute that. Now, in order to define the tool, what we need to do is we need to write the function. That's what we discussed. So let's write one Python function. So we will be writing a calculator as one of the simple functions. So let me copy that particular code. So you can see we are using from typing annotated and literal. So annotated and literal is required to typecast your type of the data that you are passing. So under operator, you have set the literal. So this literal will take care of passing only these particular values like plus, minus, asterisk, and division. Only these values it will pass, and if there is any value apart from this, it will fail the data checks. And as you can see, this is the calculator function that we have written. Very simple function which takes two integer a and b, and then in operator we are passing the operator type. So this is the operator type that we are passing these four values, and the output again we have typecasted the output to integer format. Now the simple function that we have written, if operator is plus, return a plus b. If it is minus, then perform the subtraction, then multiplication and division, or else invalid operator. Very simple function. Now, whenever we are writing the tool, please make sure that you write all these details, because if you see, this is the instructions that will be fed to the agent. So agent will get to know the idea, because the agent reads this particular function metadata, that okay, what are the details that you are passing, like what is the type of integer, what is the type of your first argument, what is the type of second argument, what is the type that it is returning. That's where it helps your agent to understand your code better. So always make sure you provide all the details. Also provide the docstring. Whenever if you are adding any docstring, it becomes very clear in order to for agents to execute the code or to call the code at right time. Next one is we can again define a two agent, assistant and user proxy agent, and we will be playing with those agents. So let me write down those two agents. So okay, so now we are writing a assistant agent. For that we are calling a convertible agent class. The name is assistant. A simple, you are a helpful AI assistant. You can help with simple calculation. So that's what we have given. The task of assistant agent is to perform a calculation. And again, at the end, it should return the terminate. And for LLM config, we are passing LLM config. This LLM config we have already defined into the LLM config.py file. So let me show you that file once again. This is the LLM config where we are using the Azure OpenAI service, and these are the details that we have stored into the .env file, where we are passing the Azure endpoint, model endpoint, and the Azure API model key. You can use this particular OpenAI subscription if you have a OpenAI subscription and the OpenAI API valid key. Then you can use this particular code and you can comment out the below one. As we have the Azure OpenAI service, so account created, and we have deployed the GPT-4 model, so we'll continue with this particular service. So once we are calling the LLM config and passing to the agent, so this agent has a LLM capability now. And let's add the user proxy agent. So for user proxy agent, again we are using a conversable agent class. The name is user. LLM configuration is not required because this particular user proxy agent will only perform a task of passing the inputs and handling the outputs from the assistant agent. So here we are adding a termination as is termination message type. Wherever the terminate word is available, it will terminate the flow. And we are not passing any human input mode. So let's execute that. Very simple, 2 agents that we have built. And now what we can do is we can register a tool for this particular agent. So let me copy that. So first of all, what we will be doing is we will be registering a tool signature with the assistant agent. So this is our name of a tool. And if you can see, we are passing this tool calculator. So if you remember, this calculator name will be exactly as that of our function. So if I'm hovering over here, it is showing definition calculator. So that's the function that we have written. So always give the name which is more prominent, and your agent should be able to interpret the name. And then in the user proxy, we are registering for execution, and again the calculator as the tool. So we have registered the tool function with user proxy and assistant agent. So let's execute that. And now it's time to register the functions. So in order to register the function, we can use this particular register function class from AutoGen. What it does is it converts your function into the registerable form of AutoGen. So AutoGen has its own format. So what it does is, you can see it is registering these assistant as well as user proxy agent. It is registering these particular, it is defining the type, like assistant is going to call the tool and user proxy is going to execute that particular tool. So, and the name of that particular tool is nothing but calculator, and description we have given a simple calculator. So this is required in order to pass the data in correct format for AutoGen. Now till this point we have registered the tool, and at this particular point we are registering the tool information to the agent, and we are defining what task needs to be done. So let's execute that. We can ignore the warning. And now it's time to test. So for testing, what we can do is, as we have given tool functionality as a calculator, so for the chat results from user proxy, we are initiating the chat, we are requesting assistant agent, and then message we are passing what is this particular value 44232 plus this particular equation. Now this particular equation, if you try to ask this normally to your LLMs, then your LLMs will fail. But now our LLM has a calculator capacity. So let's see how exactly it generates the report. So let's wait for the output generation. Okay, so the output, you can see it has started generating the output. Let me expand that. Okay, you can see initially user to assistant it has called and it has given this particular input. Then assistant to user suggested that, okay, we are calling a tool and tool name is calculator. So it understood that we need to call a tool in order to perform the calculation, and then it has given values as A and B and operator subtraction. So first of all, it is doing this particular bracket evaluation. You can see 232 minus 32. So it is slicing down the complete equation into small pieces where it is passing A and B. Now your function, already we have defined in your function that what are the inputs that we are passing, A and B, along with their data type. And that's where this agent is very smart enough, as you have given all the details into the docstring, into the argument data types. That's where your agent is smart enough to detect what needs to be passed to the A and what needs to be passed to the B. So it is doing the subtraction, and then it is saving that results, let's say 200. Then again it is calling the tool calculator for further equation. Now it is giving A as this value and B as 200. So now it is doing this particular divided by this particular subtraction result, and then it is doing the division operation. So response came 66, and again now it is defining A and B. So A plus the response that is generated, and at the end it will do the multiplication, and this is the final answer 221409. So this is the correct answer. So it is able to solve the equation with the help of calculator. So we have written very simple calculator function, but now agent has a smartness what exactly to pass to that function and how to generate the output and how to solve the complete equation. So isn't it interesting? Because your normal LLM won't have that particular capability. It makes it makes mistakes. You need to add a lot of things into the prompt in order to control the behavior. But with the tool, it became very easy. And at the end, it has given terminate as a run, right? And that's where we can see termination message condition met with agent user, and user agent has terminated. So let me show you how exactly the configuration tool looks like. So for this particular, if you can see in the tools, this is how it has registered the tool. So while registering, it has given type as function. In the function, it has given description, name it has given, the parameter type it has given, properties it has given A, type integer, description A, then B, type integer, description of B, operator, enumerator, it is enumerator, that is a list of different operators, its type is string, then the description, you can see, right, and it has given mandatory required A and B and operator, these three are required. So this gives the very high level overview for your agent in order to detect what needs to be passed to the functions. Now what we can do is we can give more control to our function or agent by using the Pydantic model. And as we discussed earlier, Pydantic helps you do the perform a data quality checks beforehand, and it passes the quality data or the data in right format for your function so that your function should not fail. And if the data is not in correct format, it fails the function beforehand in order to save your time. So for that, we can call a base model class from Pydantic. So if you can see, this is the Pydantic model from where we are importing base model and field. And let's define a data types of these particular parameters that we are passing. So we can create a class called calculator input. We are passing the input, and there we are passing base model. So it is inheriting the functionality of a base model that is available in Pydantic, and we just need to pass the parameter now. So you can see A, we are giving annotated integer and a small description. Then for B, it is again integer. Operator, again it is a operator which is a list of operators. Now, and the normal function. So you can see function that we have written, the functionality is same, only the input has changed. Now input, it is annotated calculator input. Instead of passing our those input, now we are passing calculator input because it is inherited from the Pydantic model with the help of base model. So this is giving more control. Now if we can, let me execute that and I'll show you how exactly the output looks like for this particular tools. But before that, let's register the tools for both the agent. So with this help of similar code, we are registering the tool for assistant and user proxy agent. Now let me show you how exactly the config looks like for the tool. Now you can see earlier the configuration was not this in depth, but here you can see it is in very depth, where it has given all the details for the configuration, and it becomes very easy for our agent to understand the configuration of function. Okay, so now what we can do is we can run this particular chat. We can initiate the chat and we can run the code. Now we are passing this particular equation. The values are different, so let's go ahead and execute this. Let's say the execution has started. Let me expand the. Okay, so now you can see from user to assistant, it has given the input. Then it has started detecting A and B and operator. So you can see A 1423 minus 123 and operator is negative. The subtraction, and that's how it has started execution one after the another. And at the end, and you can see at time to time it is calling calculator tool, and at the end it has generated result as 708. So you can go ahead and check the result of this equation is 708. So it is generating correct result, and at the end it is passing terminate as a parameter. Then the agent user terminating the chat flow. So isn't it interesting? So with the help of tools, we can control the agent behavior now. And you can see it hasn't gone into the multiple to and fro loops. Instead, it has directly called the tools, because it knows now what is the tool that is given to the agent and what capability it holds. And accordingly, it is calling the tools. Now for agent, we can pass multiple tools as well. and we can define that very cautiously in order to call the right tool at right time. So I hope this concept is very clear to you now, how we can add a tools, and we'll see few more examples going ahead. But yeah, if you really like this particular video, I would recommend go ahead and like the video, subscribe to my YouTube channel, and if you want to learn more on Azure OpenAI, then I have already created a one Udemy course where I have covered the generating LLM application with the help of Azure OpenAI service, where we have covered end-to-end the Azure OpenAI and the Azure OpenAI Foundry, where it starts with the basics plus the intermediate level. We have covered like fine-tuning GPT-4 model, the responsible AI handling, all the details I have covered. So if you are interested, go ahead and check out the course. Link is available below in the description. Please don't forget to share this particular video with your friends, and I'll see you soon in the next video. Thank you so much, and I'll see you soon in the next video. Thank you.